morning from the bunker here in Knoxville, Tennessee. We're happy to go into this. This will be the second site that we're showing the live field testing. This is going to be a 9S site. We'll have 3 webinars off of this site as well. So this is the first of the 3 for this site. So you can see right here on the screen, it's the field testing a 9S meter. So Brylan and I will be out there doing the testing. He'll be the guy with me on this for today's, for these next 3 coming up. So JP will roll it. So here's the upcoming, this is webinar number 13 of the second series. And so we've got the upcoming schedule today, as we said, field testing a 9S meter. Next week we're going to do part 2. Then the following one will be part 3. I will be here for part 2, but we'll pre-record part 3 because I'll be up in the Northeast, up training some folks. I'll be in Massachusetts and Connecticut and up there. So if anyone knows a translator they can send with me so I can understand the people in Massachusetts, I would appreciate that. So the agenda, today we're going to do a site inspection. We're going to talk about PPE a little bit that went on there at the site, a little discussion we got into. We're going to talk about meter assessment, and then we're going to do the test equipment setup at that site. Okay, so this is going to be a 9S site, and like I said, this is the first of 3. So then we'll actually get into the testing as we move on and the results of what we found there. Okay? So as you know, before I get rolling on all these, I always start out with a prayer. So we're going to start out with a prayer, and if everybody join in with me. Father, thank you so much for another day for us to learn our craft. Thank you so much for this incredible opportunity to do actual live field testing. We thank you so much for the development of these benches. It's taken training to the next level, and now we've actually been able to do live testing in the field so folks can see what they run into every day and how we handle it and how to assess it with the equipment. So thank you so much for that. And Father, just I didn't have a father that showed me any love growing up, so just thank you so much for here recently. I know for me, a personal conviction of just realizing that all that you do for us, you're in control of everything, but it all is based on love. Even things that happen to us that we don't like or aren't happy with or we think are unfortunate, still everything that you do for us is all based on love, Father. And if you didn't have that love for us, you wouldn't have allowed your Son to die on the cross. So thank you so much for that, because if he hadn't died on that cross, I wouldn't even be able to pray right now. So all of these things I ask and say according to the will of the one who paid it all, my brother, Jesus Christ. Amen. Okay, so we're going to start things out something a little different this morning. As you guys know, we always talk about this out in the field at the schools, which we had our first one, by the way, Mid-South. And so we talk about this, and the folks that actually turn the screws don't seem to get a whole lot of credit in their companies as they really should. It's just the nature of the beast in today's business world. But this morning we're actually going to do that. So I'm going to bring some folks out here that were the designers of and creators of this 3 series that you've seen so much in the webinars, and how much you've seen us use this when we've done the training. So I'm going to ask these guys to come in right now. So I'm going to try and stay out of their way. This is the brain power coming in, so I don't deserve to be in this lineup. So I will let these guys, they actually have the patents with them for the 3 series and the development of the 3 series. So these are the actual patent holders of it. And we're actually very proud of these guys. It was a lot of work. And as usually happens with these things, they weren't given this huge, long timeline, right? So it was a very compressed timeline, but they were victorious. So we really appreciate it, and all of you folks that use it out there, I'm sure are appreciative of these guys. So do you want to introduce the folks? I do. Okay. Yeah,
we've got with us Alan Blaylock and Kevin Mui. These are our 2 patent holders for all 3 of the patents that we have on the 3302. I, of course, am Steve Hudson. I was the project manager on that, but I also want to shout out, we also had Brad Alexander, Bill Fishbach, Rusty Lowry, James Nakamura, Kai Baus, and Scott Collins. That was the team that put the 3302 together, and as John mentioned, we didn't have a whole lot of time to do it, but we came together and we operated as a team and made an excellent product. And I just want to say how proud I am of these guys for that.
If ever there was an example of teamwork and working as a team, if they hadn't worked as a team, I assure you, I've heard the schedule that they had, and it's kind of shocking actually, but they're able to pull together and do this, and it's benefited all of us for the training purposes of also all you guys out there in the field that are using the 3 series to make sure the right revenue the right revenue on these meters is attained with this equipment. So we're appreciative of them, and we're appreciative of you guys as customers that have purchased the 3 Series. So I think it was about time these guys got a little credit. So I'm going to embarrass them a little bit. So nice job, fellas. Thank you so much. Thank you so much. Appreciate it. Yes, sir. Appreciate y'all, man. Thanks, fellas. Now get out of here. All right. All right, so we're going to do what we've been doing now, which is I'm still trying to get accustomed to it. Seeing my ugly mug on the webs. So on these videos. So we're going to start with, this is part 1 of a 9S site, and so we're going to go ahead and play that. Now, as I've done before, and just warning y'all, I might stop it and point at some things here on the screen, and but JP's awesome with these cameras jumping back and forth, so we might just do that, and I'm going to probably stop him several times as we're going along. But we'll go ahead and get this thing started. So this is the second of the sites that we're on. The first one was an 8S, so this is a 9S site, so we'll go ahead and roll it. So here we are at another site today, and Brylan and I are going to get out here and try and do some more testing for y'all. We're going to do like we always do. We're going to start out doing our inspection of the pole and the equipment. So we're going to take a look at what's going on up top and work our way down the pole. So we step out here and take a look. We're looking up top, and if you're watching any of the other series that we're developing on this, one of the things that has come up in other ones, and so we'll mention it now, is just looking at the transformers. One thing we noticed about them, they're all the same size, right?
Yes.
All right, so we got 3 of them. They're all the same size, which is usually indicative of what?
A Y.
A Y, that's right. So it's usually indicative of Y. Would you mention the rust that you see up there on the bottom?
I'd probably make a note of it just to let them know, you know, there's a little bit of rust starting to build up on the bottom of them. I mean, that could potentially cause a problem in the future.
Maybe a leak?
Correct.
Especially that one over there, looks like he's got some pretty deep spots on it.
Yeah.
Cool. Okay, so going back to, I'll go back. So on one of the, I don't want to make any assumptions as to what you've seen if you haven't seen one of the other ones. We had a previous site where we had said, we were told before we went out there that it was a delta, and when we showed up, we noticed, we were told it was a Y, and when we showed up out there, one of the transformers was larger than the other 2. And so when you see one of the transformers larger than the other 2, that's going to be indicative of a delta and a high C leg, right? Because you've got a different size transformer, because in the one that we were on, it was a 12208, but it was a C high leg, so we had 480 volt over on one of the transformers, so it was a larger transformer. So in this case, all 3 of the transformers were the same size, so that's indicative of a Y, okay, configuration. Now you'll notice right here that the reason we mentioned it here on here, that's something that you would probably want to make sure you let some folks know when that rust starts getting kind of deep in there like that, and you heard me mention it, you would want to let the folks know about that, because that could potentially lead to leaking of the transformer, which we of course don't want to happen. You want to keep that thing filled, you want the fluid in there, so that would be something you would probably report on there, okay? Thanks, JP. Over there, JP, you can see it's got some pretty deep rust spots, so you might want to mention that, because you definitely don't want a leaking transformer. But looking up top, we don't see anything. Nothing looks like it's been blown up there. Don't see any kind of arcing. We don't see any a lot of trash up in the cables. One thing I like, I noticed they've got something in the end of that conduit, right?
Yes, they don't have a weather head on it, but they looks like they've got some rubber down in there.
You can stop it right there.
Keeping anything.
So it's not a little thing to look and notice if you have, you're looking for something in the end of here to close up that conduit, right? Because in some cases you're out there on the site, you'll notice they've got an open conduit here. We don't want things going down the conduit. So you see they've got a cover over here and a cover over here, which we like, okay? So, and you'll go out there sometimes and see that. You'll even see sometimes where they don't have a weather head on the one going down to the can, right? So you want that. You want to cover it up because you don't like a lot of stuff falling down in there because it can potentially get behind something and cause a short or cause a problem. So we like to see on this one you've got cover, and we've got a weather head over there, so we like that. Thanks, bud. Right, so they've got some sort of a gasket or seal up in the top, so that looks good. So you can see all that. And this one's going to be, we're spoiling you on this one, having to get the stick up there, right?
Oh, yeah.
So the conductors look like they're going to be a lot easier for Brylan on this one to get up there with his stick. So you can see if as we're working our way around, you can see we got 3 stacked CTs up there over here on the right side of the pole as JP's working his way around. You see our 3 stacked CTs there. And as Brylan's doing his testing, when you get the... So yeah, we were joking with Brylan because he's spoiled, because he just needs to get on these conductors right here, right? So he needs to just get on there with his fork. He's going to need to get on these 2, and the other 2. So he's got 2 conductors per phase right here. And so this makes it really clear for him to get in there. And I guess a point to make would be, you always want to try, with your flexes, you know, you want to try and get perpendicular to the conductors, but also with these high volt probes, all right? So you wouldn't want to lay the high volt probe like this and lay it in. You want to try and get perpendicular to it, okay? So you want to be perpendicular here, and then perpendicular on your other phase. So that is one thing to keep in mind. And in this one, with it being so clear, it's a lot easier. You're not wedging up between a lot of stuff. You're not having to try and angle your fork or your high volt probe or your horseshoe, whatever you guys call it. You're not having to angle it as much. This is a pretty clean installation, which the Ys tend to be more. So in this case, it's going to be easier for him to do his stick work, is what we're talking about. And we were both chuckling about that after some of the other ones he'd had to deal with. Stick up there, we've before, if you didn't know what phase was what, it'll come out when you run the test, because it would come out as a cross phase if you're on the wrong phase. If he thought he was on A but he was on C, for instance, because normally that's where it happens, isn't it, Brylan? It's an A and C thing. Yes, you know where B is, but it's just are you on A or are you on C? So if he gets up there and he thinks he's on A but he's not, he's on C, it'll give him a cross phase error. So then he'll know and he'll be able to make an adjustment off that, and that'll tell him what phase he's on. So looking up there, we don't see anything looks too rough so far. We made a note of the rust up there. We don't see. Okay, to what I was saying there, I've had this question asked to me a lot. You know, when you get up there, you might not have everything labeled really well. You don't know which is A, B, or C phases, right? So the thing is, when you start your test, when you start testing the CTs and you've got a high volt probe on the end of your extendo stick, so what happens is you get up there on the first phase. Well, chances are this is going to be B phase. Probably. The center phase is usually going to be B phase, right? But what happens is you may be on C instead of A. Well, remember, we get that cross phase connection. It will show those phases, those phasers will be crossed. I'll have the wrong colors together, right, on my phasers or my vectors. The other thing is the piece of equipment is going to tell you cross phase connection. So when I go to take my high volt probe and I pick one of these and I put it on there and it tells me cross phase and I'm supposed to be testing A phase, then I know that I'm on C phase actually. So then I have folks use different techniques at that point. They may just start the test over, or they may go ahead and just finish and go ahead and test B and then A phase and then just, you know, start the thing over again. It's totally up to you. But how you do the test, at least you have determined now which phase is what. And it's an easy way. If you're looking up there trying to figure out which phase is up there at the top of the pole, just grab one of the outside phases and put that high volt probe up there and start the test. And if you get a cross phase, you know that you're on C instead of A, because the machine's going to start out on A phase testing, right? So if it gives you cross phase, you're on C instead of A, and then you can go from there. You've made the determination of what phase is what up there at the top of the pole, because it's not always labeled really well. Thanks. Any trash or anything like that? Nothing up in the CTs as we've seen on some other sites. So far so good. And then we start working our way down the pole, and we don't see anything too bad on the conduit here. We got a good, looks like we're connected to our pole ground right here from the can. So it looks good here. We're connected over here to the pole ground, and check that. And that was a snug connection. It wasn't loose. But we did note one thing at the base of the pole, right? Yes, you can tell where we've talked about in previous videos, talking about the pole leaning one way or something, or the ground, you know, settling. And you can see in the video right here where this pole, the dirt has settled and the pole is actually beginning to lean. And that right there, you need to make a note of that so they can come in there and refill that in, put foam in it, however the utility wants to do it. Because usually when something like that starts, right, it doesn't tend to get any better. Right. It'll start getting a little washout action under there. See right there. It's down there pretty good. Yeah. And it'll just start washing out down the hill, right? Mm-hmm. So on that downhill side, it'll just start washing out on you. Okay, so that's something you would. So you can tell that's a pretty new, it's a pretty new pole. So that would be something you would definitely want to report back, because as I said, they don't get any better. Once it starts that washout process, it just keeps washing out, right? And remember, you as the meter techs are the eyes and ears of the utility on a continuous basis at these sites. The linemen, unless they do have a dual role, the linemen usually only show up for the new construction, right? Or if there's a problem out there, or they're depending on you to report the problem. And this would be one you definitely want to let somebody know about, because it's not that old of a pole there. So you can see it's not that old of an installation. And that's washed out back there pretty good. You can see when we dumped it, it's pretty deep, and it's just going to continue to get worse and worse and worse, okay? So you'll definitely want to let them know about that. Definitely want to make a note of. The pole looks like it's in good shape. It's just got some washout around the base of it. And while we're out here, we may as well point something out. You know, with the utility company, there's a lot of differentiation on what equipment that you have to wear, safety equipment, depending on what you're dealing with at the site, the voltages that we're dealing with, right? So they've put a label here showing 277, 480 volt, you know, so they realize if someone walked up there and looked at this, they knew it wouldn't be a straight 480 site. This is a 277, 480 site, but this number right here might let someone know what safety equipment they need to be wearing, what level of PPE they need to be wearing, okay? So you could have it on the front of the can right here, but always keep note of that at each utility company, they normally have a differentiation of at what level of voltage you have to have what level of safety and protective gear on, okay? So sometimes they'll put it right here on the front for you. If not, remember what we've been talking about looking at the front of the camera when you're looking in the meter and you're looking at the services, just keep in mind, or you may even see it up on the transformer, but just remember that sometimes when you look at this could tell you what you need to be wearing out there in the field, okay? All right. Well, let's see what we see on the equipment. Okay, you can stop it right there. So, to what I said a minute ago about that, at this utility company, if you're working on a 480 volt site, face shield's required. That's why you're seeing Brylan is wearing the face shield over here, okay? And I don't notice, can you back this thing up for just a second, or am I being a pain? Am I being a pain?
You're being a pain.
I'm sorry. So you can or can't?
I cannot.
Okay, good, okay.
I can, but it's going to be...
No. So if you had noticed a second ago, Brylan was pressing and checking all of his wires off the bottom side of that test switch, and I should have stopped, my bad. But you'll see why here in just a second. But off the inspection process of inside the can, he discovers something we're going to see here in just a second. But that's why he's got the face shield on. At this utility, if it's 480 volt, face shield is required, okay?
Over here on the equipment, I've got this side in as a 9S, 4-wire Y, 3-phase, 4-wire Y, 3 voltages, 3 currents.
Okay, stop right there. So, for some folks that are watching all these, I know I'll get a little bit repetitive, but I have to treat these as if you're just watching just this one. So if you'll notice here on the screen, this is a setup of that site. So you can see we've named it 9S demo here. The meter form we've chosen is a 9, and then the service type is a service is a 4-wire Y. Service type here, it's important to look over here and see 3 voltages, 3 currents, and that is typical of a Y, right? But for other services, you might not have 3 voltages and 3 currents. So when you're setting up your machines to do a test, make sure you have the correct service type in there. This will get you into a lot of trouble as far as why isn't it working? Why am I getting these funky numbers? Why is this site not testing right? You got to make sure that you correctly pair the right service type with the service that you're testing, and the number of voltages and currents are important, all right? So if they're only using 2 CTs instead of 3, and they've got 2 conductors running through the same CT, you got to look at that stuff and decide, is it 3 voltages and 3 currents or not? And that way you will have the correct service type with that site, and then it'll test correctly. Otherwise, you're going to get funky numbers, you're going to wonder what's going on, and you got to be careful what it defaults to. When you choose different sites, we tested an 8S site in the previous webinar, and when we chose that 8S site, okay, it defaulted to, I believe it was 2 voltages, 3 currents, but whatever it defaulted to was not correct for it. You had to drop down and pick out the correct service type. So you need to make sure that you're pairing up the correct service type with the service that you're actually testing, or it's going to be a pain in the rump. And you also want to make sure you always get the correct K sub T on whatever equipment you're using, because anybody's equipment is going to default to a number. and you don't want to default to the incorrect K sub t. For our equipment, it's 1. So if it defaults to a 1 and you don't enter that in there, you're also going to get some weird percentage of registration, okay? Thanks.
Our K sub t on this meter is 1.8. You can come in here, and in this one, it's not up in the far corner somewhere. It's down here in the bottom right corner. You can see right there where it says 1.8. But you do have your Y up here on the screen in the right corner. And this is 277 480 volt.
Right there.
So that's where all that.
Okay, so we've talked about this before, but you know, when you go up there before you start testing, gather up your information and make sure that you're putting the correct service type in, what you're about to test, what you're dealing with, and you have information off the actual nameplate and face of that meter, and then also off the display screen, right? So on the display screen, usually you're going to have either a Y or a delta for whether it's a Y or a delta service. You're also going to show that minimum voltage right there, right? So it's 277. So if it's a Y, we're going to say it's a 277 480 volt Y is how we say the configuration is on that. Then down here, you've got the K sub H is 1.8. So what that means is, we call it K sub T for testing, but the K sub T there is we're saying, okay, for every 1.8 watts, I should get a pulse. So that's what you keep in mind as you're doing your testing, okay? Every 1.8 watts on that meter, I should get a pulse. Back in the day, it was 1 revolution of the old electromechanicals, right? Also, you'll see on there it has TA equals 2.5. That 2.5 is important to us because if you're doing a phantom load test at this site, right, where you're going to generate the load on there, that TA 2.5 is now your full load. So my full load is 2.5 amps, right? And remember, my light load, there's 3 tests, full load, power factor, light load. My full load is the 2.5 right there off the face of the meter. It tells you, so you always know what your full load is going to be from the face of the meter, the TA, 2.5. Then according to ANSI, my light load is always 1/10 of that, so it's going to be 0.25. Just slide that decimal to the left one, right? So that's divided by 10. So now I've got 0.25, and then my power factor is always 0.5 is what I use, which is a bad power factor, which equates to a really wide angle, 60-degree angle, which would be horrible. You'd be losing your behind, right? Because remember, it's voltage times current times power factor equals watts. So if I took my voltage and my current and multiplied by 0.5, I'm already cutting it in half, and I'm losing half of my revenue right off the top. So you're doing a test of putting a good load on it, a really jacked up power factor, and then a very light load on there, okay? And that is that phantom load test. But you glean the full load right off the face of that meter. Other important stuff off the face here is it's a class 20 meter, so it's made to handle 20 amps, okay? Whereas if you saw a class CL 200, it would be that meter would be made to handle 200 amps. But this is a class 20 meter. That's why you have the test switches, the CTs and everything to bring it down. We always say they're step down transformers for a VT or a voltage transformer or a PT potential transformer. It brings the voltage down. Then our CTs or current transformers brings the current down because this is a class 20 meter, so it's made to work with 20 amps, okay, max. Otherwise, if you get over that, it's not good. And it also says on here it's a form 9S or 8S. And if it was a delta site, then it would be an 8S, but this is a Y site, so it's a 9S, so it's functioning as a 9S. All that you just get off of here, okay, before you've even got started. So you've done an inspection of the pole, inspection up top, come down. Now you've gotten to this point where you've gathered information off of that meter before you've actually started the test as well. Another thing you can look for, I can look for my bar going across there to see if I've got much load on there as well. If it's not moving and I don't have any load there, then I know that I'm probably going to have to perform a phantom load test, right? And I can't do a customer load test because I don't have any movement across there. Okay, so all of that stuff, I haven't even cracked anything open yet, and already I know all that information. Okay? Thanks, bud.
Information comes from, and I've got it in here, set up, ready to rock and roll.
So did y'all catch what he was saying? You looked up there and you saw that it was a Y on the screen like we've been talking about, right? It's a Y on the screen like we've been talking about right there. And it also says it on the face right there. It's telling you it's at 1.8.
which is typical of your 9S meters. So we've noticed that up there that it is a Y. If it was a delta, it could be an 8, but this is a Y, so it is a 9. So it is typically on these transformer rated meters, you have 1.8 as your K sub T, which we may as well say this, we haven't said it yet, but what that means is for every 1.8 watts, you get a pulse. Okay, so that's what's happening. It is giving you a pulse over every 1.8 watts. So that's what we're looking for. So when you're doing your tests with the equipment, remember when it's doing like a customer load test, it'll say, okay, I've got pulses expected versus pulses actual. The pulses actual are picked up off of the pickup that Brylan's going to put on there on the hog nose or that COM port on the front of it, and it's going to count the pulses. 1, 2, 3. Those are the pulses that are. You have the pulses actual and then pulses expected. And the pulses expected is where we measure, we take voltage times current times power factor, we come up with watts, right? And then for this meter, you divide by 1.8, and it tells you how many pulses you should have had. And so you've always seen those comparisons in the webinars we've done before where it says, okay, I actually counted the pulses, my actual 1, 2, 3 with that pickup, but then when we measured it, it came out, well, we counted 3 pulses, but actually off of the measurements that we made, it was actually should have been 2.995, for instance. It'll make a comparison of those two numbers, and that becomes your percent registration of accuracy for that meter under a customer load, where it's using all of the CTs, all the wiring, and everything else here. It's not a phantom load test. This is a customer load test. So it tells you what's actually going on at the customer, which you can hear the noise behind you and know that we do have a customer right here going. So it's telling you what's going on behind that wall, right? Because it's taking all of the connections and everything into account and the CTs, whereas a phantom load test is where you pull that meter or you disconnect it from those CTs and all that wiring, and you just test just that meter. You run it off of a load box here in the field. You can use a load box like we have here and run that phantom load test, or you can use a customer load test like we're going to do now and use the CTs and what's the actual load of the customer, what's going on today. For a customer complaint, we actually say that it would probably be better to use that customer load test, because you can say the equipment gives you a date and time stamp on it, and you can say we're here at Thursday at 2 o'clock under actual load here, Mr. Customer, and here's what we got, here's what we had, in case they have a complaint about anything. So we're going to go ahead and hook her up?
Yep. One thing I wanted to talk about here is you can tell where something has arced back here in the back of this can. And it's got all the black smudge all over it and everything like that. So you just want to look around and see, is that something that's happened previously, or has that happened, you know, they've had to come out here and fix it, or what, to make sure everything, all the wire looks good, nothing's loose. And I don't know if you could see before, I was checking all the wires to make sure they're all good and tight. None of them's loose, has slipped out or anything like that.
Okay.
And they all look pretty good. So I think that's just something that's happened before, and they've had come out here and fixed it, you know,
right.
Something like that. So we'll go ahead and hook everything up.
Okay, one thing I meant to say right there, and I didn't say it loud enough, that was my bad, so JP would stop. But right there at the very end, if you notice the phenomenon, is it a pain in the butt just to rewind to that last little part, JP?
Give me just a second.
Okay.
Right here?
Cool, yeah, perfect. All right. So we've talked about this before. There's also, you noticed that he was checking his wires. He had seen that he had the arcing back there, right? Well, also when we looked at it, you could tell that this is a new test switch, okay? So you can tell because looking at previous test switches, this one was a little bit different. So it's a key when you get up there too, for me anyway. Of course, if you've worked there for a long time at your utility, then you know the layout of you know your test switches because you've seen them a lot. But let's say you're new working at the utility. I just want to make sure we talk about the assessment of also the test switch. What's what at the test switch? Because that's where you're going to make your connections at the transformer rated sites. If you have test switches, you're going to make your connections at that test switch, right, to do your testing. So when you're looking at this, if I'm looking at this test switch right here, I notice that I always know that the phenolic barriers, these black plastic barriers, which I have one, they're right behind me on the training bench. These barriers right here are always going to be between the phases so that you don't go phase to phase with the voltages, okay? Now in this case, when you look here, you've got, if I look right here, I can see that this is a long stroke blade, right? I can see a long stroke blade there, and I can see here so when I'm there, I usually I open some things up to see what's what. If you see this piece of metal, I hope you can see it, there's a piece of metal that comes across the front of this right here on this switch. If you were to open that switch up, that's going to be a shunt switch. It'll be a short stroke switch, so it's not going to open up very far. That's the shunting switch, okay? It shunts the CTs. Right, just beside it right here, you can see that pattern right there allows you to insert the duck bills. So it's a cross pattern right there for you to insert the duck bills right there, okay? Now you'll notice, now we're going to the next phase. This is my phase voltage here. Now since I'm going to a new phase of voltage, I phenolic buried it off right here. So I've buried it off. I've got barriers right here. So I've got the barriers between it, and that's my next phase, and that's my next phase, right, voltage-wise. So that tells me in this one I've just got blacks and reds. So I know here I got a voltage, and a voltage, neutral white over here on the far right, okay? But here's where I've got my phenolics, and my phenolics separating the voltages. You'll always have phenolics around your voltages. Sometimes they're not. It's a different configuration, and you'll have it. And is there any way they can see right behind here? Do you have anything right here, JP, that you can see? Maybe. He's going to work the magic, baby. Can you zoom in a little bit? Or?
I'm working on it.
Just asking.
I'm pushing buttons over here.
I can hear clicking. I know there's clicking going on.
I can move the camera.
Okay, if you want to.
Give me another second.
Make him earn his pay, baby. By the way, I hope y'all noticed, I mean, you talk about some serious camera work. Did y'all see how clear that was at the top of the pole? It kind of freaked me out a little bit. And I joked with JP and said, dang, you can even see hairs on my ears, man, which I didn't like. But, I mean, it's incredible, the camera work, and how clear everything is. So, all right, awesome.
Going to be a second.
No problem.
You want to move that water bottle?
No. Cool. The JP magic. Don't look behind the curtain at the great and powerful laws. Okay. Cool. Boom. All right. So remember we were talking about, and this is not hot, the light's not on, so this is dead, just so everybody knows. Okay, so, because I didn't want to get up here with my bare hand, but if you'll look right here, remember I talked about the phenolics between the voltages. Well, look here, this test switch is set up totally different because I have all of my returns are over here to the right where these duck bills are in here. So that's where those patterns are, right, with the cross pattern that we see over there that I just pointed to on the screen over there. So now, let me come around here. They've got the phenolics between each one of these to separate those voltage phases, okay? Because here, you can see here, that's a shunt blade, short stroke. Remember I talked about that piece of metal that comes around the front. That's what catches it, stops it from making a full swing. So that is my shunt blade and my shunt switch, okay? So beside it is the voltage. This is a long stroke blade right here. So I've got shunt, voltage, shunt, voltage, shunt, voltage, and then I've got my neutral, and all of my returns with my duck bills are over here. So you don't see any phenolics over here, right? Because I'm going to separate my voltages and make sure my voltages are separated with those phenolic barriers. So you can use the phenolics to help guide you on what is the layout of that test switch when you first show up at one you haven't seen before, okay? So you got some keys there. Look for the short stroke blade, and then also you can marry the colors. Hopefully there is some color coding. If there's not, like on the one we looked at over here on the screen, there's not. But in this case, my shunt blade here is orange, and my return handle over there is orange. So I've married up A phase shunt, A phase return, B phase shunt, B phase return, C phase shunt, C phase return. Okay? So you can get the layout of the switch to know where you make your connections, because you see on here, we've actually connected our voltages, red, yellow, blue there. We've connected our 3 currents over here with our duck bills over here to this side over here. And then we got our pickup up in the top. So learn, when you get there, if it's not a test switch that you recognize or you're new, then you can use those little tricks to try and figure out the layout, because it's critical to how you make your connections, right? Thanks, JP. Oh, I'm trying to drag a wire. Okay, so you saw where the upcoming schedule is. We've got May 18th will be part 2, and May 25th will be 3. Got a note on there that says register now using the button below the video player. You won't get any emails. I like the way he put in italics any. So we just go ahead and register, and we hope to see you guys for parts 2 and 3 to complete the testing of this site on this 9S. But thank y'all so much for joining, and we're pretty tickled that we can do these actual field tests for you guys, and hopefully it helps, but more importantly, it helps you do your job, but more importantly, hopefully keep somebody from making a mistake and maybe getting hurt and not making it home to their families the way they left for work. So thank you guys again. God bless. Be careful out there, all right?